How did the LS compete with this? This is so much better. What we have here is a forged steel, fully counterweighted crankshaft. This is like some race car stuff right here. So this is both better in design as well as fastener size. This is just better than anything out there that I have seen. So piston should be ready to rock for that same level of output. But again, we're dealing with a different rod material than what I'm used to. So it might hold a little bit more. And this is a beautiful intake port. I'm really impressed with this. What if you just put the thing together and put a turbo on it and ran it stock? Alright guys, it's time to introduce a new platform to the channel. And that is what you're looking at right here. This is a Nissan VK56 that came out of a Nissan Titan truck. Now at the most recent running of the Streetcar Bragging Rights event that takes place in Rockingham, North Carolina, a man named John Rogers put one of these engines into his 240SX and showed that this engine, with not a lot of modification, was capable of over 2,000 horsepower. And he was able to get his 240SX to go over 200 miles per hour in the quarter. His success has brought a lot of attention to the platform and has earned the engine the tagline, the Tokyote. Basically, they are taking Tokyo, where the engine was produced, and Coyote, and combining the two, and meet the Tokyote. After we saw how successful he was, we became very interested in the platform because they can be had for right around LS prices. My dad just picked this one up for $700 right out of a junkyard, pulled with a seat belt for proof. And we're going to tear the engine down today and have a look at some of the internals. So why is this engine so great? What we have here is an aluminum block, aluminum head, dual overhead cam V8 engine. These engines are widely available in junkyards and they can be had for right around the same price as an LS. So let's go over the specs of this engine. This engine was offered in the Nissan truck platforms from around 2004 to around 2016. It features a 98mm bore with a 92mm stroke, and I love it when an engine has a bigger bore than it does stroke. The bore is the same as what you would see on a 5.3 liter to 6.2 series LS, but it has a bore in between a 5.3 liter and a 6 liter. Oddly enough, they are within a couple thousandths of an inch of the same bore spacing as an LS, but what you get with this engine package is a dual overhead cam. And you guys know I'm a big fan of dual overhead cams. You have a much lighter weight valve train, and that supports high RPM use much better than a push rod engine. Also, you usually get superior cylinder head flow through the head. So essentially we have an LS with dual overhead cams, and it didn't really cost us that much more. Now, these engines were pretty weak from the factory. They only produced like 317 to 320 horsepower at a pretty low RPM. It's only 4,900 RPM is where the power peak was. So you can tell that these engines were probably very undercammed. I'm sure a set of cams in one of these engines would wake it way up, and we'll get into that a little bit later. So let's get into the teardown and see what this thing has inside of it. there. I wish GM would put these on theirs. You can actually, like, you know, check the timing on your engine. That's crazy. All right, leave a comment. Just took the throttle body off. What the heck is this thing? What is that? Why? Why is this here? Tell me. All right, guys, now that we have it torn down to no accessories, no intake, I've drained the oil out of it, and it has no coolant in it. I thought this was a good time to actually weigh this thing, and hopefully we can compare it to some other common engine choices. So let's get this thing lowered down and see how much it weighs. All right, guys, we have it on the scale, and this thing's actually pretty light. 356 pounds for a bare long block, no oil, no coolant. Next, we're going to throw an LS onto the scale and see how much it weighs. All right, next up we have an LS. This is a 416 stroker in an LS3 block, so aluminum block LS. Let's lower it onto the scale. The damper is not on the front of the engine, so I just grabbed a damper that we had laying around and put it on top. So let's get this thing lowered down and see what it weighs. All right, 325. So for another 41 pounds, you get dual overhead cams and a way better architecture, but we'll get into that in a second. All right, just for fun, I thought I would throw a North Star onto the scale. I know a lot of you probably aren't considering this as an option, but I was just curious. So let's drop this thing onto the scale and see what we got. All right, it is on the scale. Granted, it does not have an oil pan on it, so it's not a truly fair comparison, but it comes in at 350 pounds. So it is right around the same weight as the VK56, maybe just slightly more because, again, we don't have an oil pan on it. So with that out of the way, let's get back to the VK56 and tear it the rest of the way down.
There's videos and like, okay.
Oh wow, look at that. All right, we got the valve cover off and I'm about to start pulling the head. One thing that's kind of annoying is you do have to pull the cams off in order to get the head bolts out. Not a huge deal, but on a 4200 you can actually keep the cams in the head. Makes it a little easier, but I kind of wanted to stop and comment on the valve train style. This is what they call a cam on bucket. Basically the cam pushes right down on top of a bucket which sits right on top of the retainer and the spring. That means that all of your lift here is encompassed in this lobe. There is no rocker ratio or anything like that. Now I will say this results in a lower valve train weight, so it should like to RPM more, but if I'm being honest, I kind of like the way that the Coyote and the 4200 and the later North Stars as well. I like how the valve train is set up on them because they have what's called a follower, and it has a little roller and it has a ratio, and there's a little lash adjuster which adjusts over time, and as the engine wears, that little lash adjuster will take up the slack, whereas I believe this system is 100% mechanical. This would be more close to like a flat tappet style pushrod engine, whereas like a Coyote or a 4200 would be like a roller cam. Now, that being said, the 2JZ is arranged exactly like this engine is, and they're incredibly reliable, and there's guys making tons of horsepower with them very reliably. So this doesn't scare me, it's just different. One other thing to take note on this cylinder head is I don't see a lot of provisions for oil drain back. This is a problem that is present on the Nissan RB26. In fact, a lot of times they will install a rear head drain on the back of those engines in order to help with oil drain back. And it looks like this engine does not have a lot of provision down inside to help with oil drain back. We could very easily take this freeze plug out of the back of the engine and make a little flange that bolts on here and help with oil drain back. But we'll have to see how it does. We'll probably fabricate an oil pan with quite a bit of oil pan capacity so that even if the oil gets trapped up here in the head, we have plenty of oil to keep the engine supplied. So next, let's get these cams pulled off, and then we can pull the head bolts out and get this engine the rest of the way disassembled. Alright, I got the inspection covers tore off the front of this engine, and I gotta say, man, I wish GM spent this amount of time thinking about how you're actually going to service the engine. As you can see, we got 3 covers here. We got one cover down here. This is to get the passenger side bank timing chain tensioner. Then we have another inspection cover here to look at our cam sprockets. And then on the driver's side, it's all integrated into one. You can get to your timing chain tensioner right here, and then our 2 timing sprockets up here without even pulling the front cover. I bet you could get these off without even pulling the accessories off the engine. This is what good engineering looks like. You should give your service techs and engineers like myself who like to get their hands dirty, you should give us an opportunity to be able to get into the items that may need to be commonly inspected or serviced. Alright, now that we have the front cover off, we got to talk about something that Nissan typically struggles with, and that is the oil pump. If you guys are familiar with the Nissan RB26 and some of the other Nissan series engines, you know that those engines struggle with the oil pump failing at high output. In fact, they struggle at low output as well, and I think it has to do with this design right here. If you look closely here, you'll see that the actual drive for the oil pump is sort of this 2-flat system. On an LS, it's more of like a splined input, and I believe that this 2-flat style drive system causes the inner gear on the gear rotor style pump to experience forces in the radial direction, and it causes the internal gear to want to spread apart and basically just fly apart into a million pieces. In fact, the Coyote engines have the same style drive system, and they experience the same style of failure. So on RB26s and on Coyotes, what they do is they upgrade the gears inside of this pump to a stronger material that is able to cope with the forces of this drive style. I will have to look and see if someone offers an upgraded set of gears for this oil pump, because I think it's probably going to be required, and if we have it this far torn apart, we probably should be looking into that. This is probably why John Rogers has gone to a dry sump on his engine, but we're trying to keep the cost down and trying to build something that's a little more budget friendly. So I would really like to reuse this oil pump if we can. Alright guys, we got the cylinder head pulled off and we got a lot to talk about here. So first off, here are the cylinder head drains right here in the bottom. They're a little small. I'd like to see a little bit larger head drain, but that being said, these will provide a lot of stiffening to the block because these tunnels here turn into kind of a strengthening rib on the engine. Next, I gotta say, I'm very impressed with the amount of support around the sleeve. The sleeves on these things are pretty dang thick. They're like a 1/4 inch thick. Now, one thing that you'll see on the Coyotes is they go to the Voodoo block when they want to make extreme horsepower. And the reason that they do that is that on standard Coyote blocks, they look more like an LS, where this area of the block does not have support from the head bolt. But the Voodoo block has a little bit more webbing in the deck surface, specifically in this area that bridges to the head bolt. Now, the deck surface on this thing is way more substantial than even the Voodoo block. If you see this area right here, there is tons of support in this area, as well as at the bottom. And I can see why John Rogers is getting close to 2,000 wheel horsepower with a factory cylinder block. Next, I'm going to go grab an LS cylinder head and show you why this is so much better than the LS. If I lay the VK56 head gasket over top of the LS, you can see how much closer this head bolt right here is to the actual bore itself. This is actually an upgrade that Steve Morris does to his SML series engines. He moves this head stud right here closer to the bore in order to make the clamping more centered around the bore. And the fact that this engine is just arranged like that from the factory tells me that it's going to hold the head down in a much better way. This is something that LSs struggle quite a bit with when you get to high horsepower application. And, even when you go to the 6-bolt arrangement on the LS, basically the studs are so far away from the sleeve that they still have some issues. This is why you see on Coyotes and, of course, this thing, they're making 2,000 wheel horsepower with 4 bolts per cylinder. The studs are much closer to the bores, and therefore you get a much better clamping surface around the bore of the engine, and that's obviously where you need the clamping force. Also, the LS features a 11 millimeter stud, but this VK56 features a 12 millimeter stud right from the factory, so this stud is going to provide much better clamping force. So this is both better in design as well as fastener size. This is just better than anything out there that I have seen. It's no wonder that John is having so much success. All right, guys, while we have the cylinder head pulled off, we got to talk about these intake ports. I gotta say, I don't know what I would do to improve this port. Like, if I was looking at this port from a head porter's perspective, the transition to the valve seat is amazing. The fact that the leading edge of this surface right here, where it splits to the 2 valves, is rounded. That's what you want. You might be able to enlarge it a little bit, but this is a beautiful intake port. I'm really impressed with this. Let's move over to the exhaust now. The exhaust probably could be a little bit bigger. It looks like it has a little bit of a dog leg in it. It looks like it sort of narrows towards the center of the engine. But overall, you might be able to thin down the area where the valve seal and the, where the valve comes down into the port. But yeah, not a lot to improve there. It does look like it's an adequately sized port, unlike the 4200s. Let's move on to the chamber. Looks pretty fantastic as well. It doesn't look like the valves are shrouded too much. You might be able to get away with a little bit larger valve on this thing. You might be able to remove some area right here. There might be a little bit of shrouding in this area. But, overall, that's a fairly decent combustion chamber. It's pretty hard to screw up a 4 valve. So yeah, I'm impressed. This is quite the cylinder head. As far as the deck thickness of the head, it looks like it's not the most thick thing ever, but with all this webbing in the surface here, I don't think it would be too much of a concern. Overall, very well designed head. This thing is beautiful, man. This is crazy. All right, while we have the cams out, I would like to measure some of the specs of the camshaft. I don't have a cam doctor, so we can't really measure the duration, but we can measure the gross lift of this camshaft. Again, these cams are pushing directly down onto the valve spring. So the lift that we see here at the lobe is the lift that we're going to see at the valve. So let's use the old dial caliper, measure the base circle, and I'm coming up with 1.400. And then the lobe dimension is 1.755-ish. So that gives us 355 thousandths of intake lift. That's pretty weak, I'll be honest. It looks like it's a pretty anemic cam. Next, let's look at the exhaust cam. Hopefully it's a little bit larger to compensate for the smaller port. The base circle looks to be that same 1.400. And then the lobe dimension appears to be right around that same 1.755. So looks like it's about the same. So I would say that this thing could benefit from a more aggressive set of cams. Those are definitely pretty weak, but we won't know until we actually run this thing. All right, next I'm going to flip this engine over. We're going to look at the bottom end. I'll pull a rod and piston, and we will make some more comparisons. All right, guys. Wow, this is impressive. How did the LS compete with this? This is so much better. What we have here is a forged steel, fully counterweighted crankshaft. This is like some race car stuff right here. It is so rare to see a fully counterweighted V8 crank in a factory application. And they stuck these things in trucks. And look at the main caps. These things are beefy, and they feature an M10 bolt that comes in from the side, which is much larger than what the LS has, which is only an M8. You can really see why this is such a beefy bottom end, and why John is getting so much horsepower from a stock crank and stock block. Even these rods look pretty substantial. I'm interested to get these pulled apart and dropped out of the engine, but I gotta say, I'm super impressed. I don't know how these engines weren't discovered sooner. Another thing to talk about with the bottom end is if we look down inside, right at the bottom of the sleeve where, you know, the skirt is, kind of down in this area, you'll see that when the piston is pulled all the way down by the connecting rod, it never actually pulls the skirt down below the sleeve. This is something that you see a lot of times on the LS engines, particularly with like strokers, even some of the factory stuff. They will actually pull the piston down out the bottom of the bore, and it causes the piston to sort of rock back and forth. Actually, 4200s are the same way. They have a 4-inch stroke. But it's nice to see that the sleeve is extended long enough. You know, they made the deck height high enough that it fully supports the piston when the piston is all the way down at the bottom. So very, very impressive. Let's get one of these rods and pistons pulled out and start doing some comparing. Next, let's talk about the rod and piston itself. The piston appears to be a fairly decent design. Not a ton of ringland, but nothing I'm afraid of. Nothing too much worse than what like you would see on a 4200. The pin is a very lightweight pin. You can see it's sort of tapered on the ends in order to make it as light as possible and, you know, only provide the beef where it is needed. The rod itself is actually kind of funny. You can see there's this little hole here in the bearing, and there's actually a piston oil squirter in the rod, very similar to what you see in a 4200. We have a lot of experience with this type of arrangement. It helps to keep the piston from scuffing. On the thrust side, you can see that it has started to scuff a little bit. Oddly enough, it sprays onto the non-thrust side. That's a little weird. I don't think I fully understand that one. Yeah, let me think about this. So when it's coming down, it's rotating this way. So, okay, it is spraying on the thrust side, but it appears the non-thrust side has seen a little bit of impregnation into the skirt. A little weird. But anyways, the connecting rod appears to be a forged steel connecting rod. It appears to be a pretty well-designed piece. This is opposed to like what you see on the GM stuff, where it is the powdered metal style connecting rods. I would bet that this construction here is able to hold a lot more horsepower per, you know, cross-sectional area. Basically, the tensile strength is higher on something like this than a powdered metal rod. But let's compare this to a 4200 rod and an LS rod, and then we'll make some judgments on how much power I think this thing could make stock bottom end. All right, guys, let's talk about the rod and piston on this thing. So I'm going to zoom this in a little bit here and show you this thing up close compared to some other platforms that we have featured on this channel. All right, so here is the Nissan VK56 rod, and here is a Vortec 4200. The beam looks to be a little bit wider on the VK56, but it looks to be a little thinner in the width dimension. I'm very comfortable with the 4200 rod and piston combo at around 150 horsepower per cylinder. If we look at the tops of the pistons, you'll see that the VK56 has a little bit more ringland than the 4200, so piston should be ready to rock for that same level of output. But again, we're dealing with a different rod material than what I'm used to, so it might hold a little bit more. Next, we're going to grab a Gen 5 5.3 liter rod and piston. These rods are the same as a Gen 4 LS, and you can see how much more substantial the Gen 4 LS rod is than the VK56. It's slightly more thick in the length dimension, way more thick in the width dimension. So Gen 4 LS rod definitely a lot more beefy. The ringland on the Gen 5 LT series piston is definitely more substantial than what we see on the VK56. So if I were to make a judgment on what I think that this rod and piston combo would be good for, I would say right around that 800 to 1,000 wheel horsepower mark. I think 1,000 would be starting to push it pretty hard. But around that 800 to 900 horsepower area, I think this would last a long time, but we'll have to see what this thing can do. Obviously, a lot of your connecting rod strength comes from how does your torque converter couple. If it couples at a very low RPM or drags the engine down on a shift, this rod is not going to last. Also, what does your cam profile look like? Does it favor a higher RPM power production and kill some of your bottom end? This is actually a common strategy that we use on the 4200s by putting aftermarket cams in. You kill some of that torque and you're able to make this stock rod make a little more horsepower. So a lot of that plays into it. Hopefully we can get a cam package into this thing that will make it RPM, and we will definitely put a torque converter package into this thing such that it will not drag the engine down and cause it to fold a rod just because of something dumb like that. All right, decided to pull the center main cap just to have a look at the thrust bearing, And it is nice to see a 360-degree thrust. Seems like a lot of modern engines are getting away from that. But I do see the first thing that I don't particularly like, and that is the crankshaft is cross-drilled. So what that means is that the oiling going into the main journal has to go straight through towards the center of the crankshaft, and then there is a drill hole that goes up to your rod bearing, which intersects with that cross drill. The problem is that when the engine is at high RPM and there's lots of centrifugal force pushing the oil outward, a lot of times it will have difficulty getting down towards the center of the crankshaft and then back out to the rod bearings. This is a problem that they have on 2JZ engines. Those cranks are factory cross-drilled crankshafts, and when they go to aftermarket cranks, they go to what is called a direct oiling style system. That being said, John is running this thing up to 10,000 RPM, and he's not having an issue with that cross drill. And this is actually kind of encouraging for our North Star development as well, because those cranks are cross-drilled as well. If he's not having an issue, hopefully we don't have an issue, and hopefully we are able to make that cross-drill work for what we need it to do. Another thing to talk about with the main cap is the fastener size. On an LS, you would see two M10 by 2.0 fasteners on either side of the crankshaft and an M8 bolt coming in from the side. And on this we see a much more beefy setup. The two bolts that are closest to the crankshaft are an M12, and the two bolts on the outside are actually an M9, kind of a weird fastener size. And then the bolts coming in from the side are an M10. So this should provide a whole lot more clamping force and a lot more force coming in from the side, keeping the block together. So clearly we got ourselves quite the piece here. A lot of fasteners holding this thing together, and a lot more beefy than what you see on an LS. Overall, I gotta say I'm extremely impressed with this engine. The cylinder heads, wow. The amount of webbing in the deck surface, wow. The head bolt size and the head bolt placement around the sleeve, wow. The crankshaft being a fully counterweighted crankshaft with 6-bolt main and much heavier fasteners than what you see on an LS. Wow, I can see why this engine is holding extreme amounts of power in John Rogers' 240SX. But the problem is, with his application, what he's not telling you is how much money he has invested in the parts that actually bolt to the engine. Yes, these engines have a decent amount of aftermarket support. They're very popular over in New Zealand in circuit racing, but it's pretty low volume and it's a Nissan engine, so it's pretty expensive. For a max effort set of camshafts, you're looking at $1,800. For a max effort set of valve springs, you're looking at another $1,800. If you went with something more mild, cams don't cost any more or less, but your valve springs will come down in price a little bit. But you're still going to have well over $2,000 in the cam and spring package. Another thing that I want to address on this engine is where the crankshaft reluctor is on this engine. It's actually on the flywheel, and the crank sensor must be a provision in the bell housing of the transmission. I would much rather go to a front crank trigger style setup, so we will definitely be doing that. That will require some sort of SFI damper that has bolting provisions in the damper so that we can bolt a trigger wheel to the front of it. That's a little more cost that you won't have to do with an LS. Now, if you want to go for extreme horsepower, forged rods and pistons are available for this engine as well. They're also a little pricey. A set of rods from Molnar is right around $1,100, and a set of forged pistons is around $2,500. I'm sure we could work with somebody and get a better price on that. I don't know why a set of pistons has to cost that much. That seems a little excessive. And another thing that we got to talk about is the oiling system. On John Rogers' 240SX, he went with a dry sump oiling system. I'm sure that was to deal with any issues that there might be with oil drain back or with the oil pump itself. Nissan's kind of notorious for having bad oil pump design for high output applications, so he went with a dry sump oiling system. Those setups, not cheap either. But as I was doing more and more research on this platform, I kept coming back to a question in my mind. What if you just put the thing together and put a turbo on it and ran it stock? How much horsepower could we get out of it? Basically, what can we do with this thing with spending as little as possible on the thing? So that is where we are going with this engine. We are going to shove this thing into something, and we're going to do it on a sort of sloppy mechanics style budget build. Rather than throwing the kitchen sink at it and spending $10,000 on an engine, we're going to start with, let's just spend $700 and do a few little upgrades where it makes sense, and follow in one of my favorite creators' footsteps and build the junkyard VK56. So with that, I'm going to end this video off here. Make sure you like, comment, and subscribe. We'll see you in the next one.